To work with our particles, just to review, we need to add the particle file and the particle system file to our project folder. So once those are inside our project folder, then we will be able to make use of them in the project. Now, to make this work, we don't have to do anything. Currently it's doing a ugly looking star as our particle. If we look here, you'll see that we can do a circle particle, a rectangle particle, or the star. If you don't like the star, which I don't like, I'm going to get rid of it. I'm going to pull back my circle. Doesn't matter. And you can change the display for the particle to be whatever you want. We will look at the particle system a little later and talk about how you can change the particulars of it. Right now we get groups of 100 particles. So every time we hit an object, it gives us the 100 particles that fly out in a circular direction. But if you are so inclined, you can do nothing, don't have to do anything to these, and we can integrate them into the project. So that's the good part about this, is we can do this without actually having to touch the particle or the particle system file. We just have to make reference to those in our main project file. The particles are groups of 100, and they get stored in an array. And the different particle arrays are the particle system. And we are going to use one particle system per drop that falls in the game. So each drop gets its own unique particle system. The advantage of doing that is we're able to make all of the particles at the beginning when we start the game, and we don't continually keep making new ones. So we have a finite amount of objects. Because if we made a new particle system every time there's a collision, the longer you played the game, eventually we would have constructed or created too many objects and it would freak out. As it is, we could optimize this if we determine what is the maximum number of particle systems that would ever be on screen at any one time, and only use that and then cycle through that as a pool of particle systems. So then it's like having a talent pool, and we just grab them as we need them. But to keep things simple, we're just going to have one particle system correspond to one drop. So if there are, in this case, I have 10 drops in my game, that means I get 10 particle systems. If I have 20 drops, I would have 20 particle systems. And that's the method that we're going to use to work with this. To make our particle systems here, what we can do with this is we need to create them, and it will be an array of particle systems. That way we can easily keep track of it. So if we think about it, it's going to be kind of like working with the drops, where we have our drops array, and then we have our number of drops, and then we have our active drops as part of it. So because we have that active drops corresponding to how many drops in our system, we're just going to work with it that way. So this means I'm going to construct an array filled with my particle system, and wrong bracket, square brackets. The square brackets indicates I'm making an array. PS is going to be my shorthand notation for particle systems, just because particle systems eventually becomes too much typing for my fingers and I got lazy. I'm going to use an integer to store my active particle system. And I'll just do active PS like that. So it's kind of like we have active drops, we have active, it's an active particle system. So active drop starts at 0 and then goes up until it maxes out. Same thing with our active particle systems. It's going to follow that same methodology. So now that we've constructed some variables, it's time to populate them. So we can put that in our game state, or in our setup here. So PS is going to be equal to new particle system, and then we get to specify how many. Now for this, I want it to correspond to how many drops are being used in my game. So I have one particle system per drop, so I will just say drops.length. So I can just put that in like that. So that now says PS is a new array filled with particle systems, and the number of particle systems in that array is the same number of the drops inside my program. Now, I like to, so I don't forget, start my active particle systems at 0, and now it becomes a matter of populating my particle systems into that array. So we're going to actually create them. This is where we get to use our standard for loop. So it's going to be just like where we put the drops inside the drop array, but we're now going to do that for our particle systems. So for int I is equal to 0, I is less than ps.length I plus plus. So I'm using the number or the length of my array, which happens to be the same as drops length. So technically I could put drops length there and that would work too because it's the same number being used. But it just makes more sense if this array is for my particle systems to go through it this way. And then we actually now say the item in my array at that position, I, is equal to a new particle system. If we look at the particle system class, we will see that its constructor does not take any properties. It doesn't take any variables. It doesn't take any, it just is. And that way we can now construct it, because what's going to happen with our particle systems is when they're running and there's a collision and we need the particles to spring out, we're going to send it some information about the location of where that collision occurred, feed that information to it, so then the particles know where they're supposed to start on screen. That's how we're able to pass that value from one object to the next object, and we'll look at that in just a moment. So at this point, we've now populated our project with our particle systems. They're not doing anything yet. We're not making them run. We're not working with them. But we can now start, now that we have them in our project, it would be a good time to actually take a peek at what these files are so we gain some understanding of how we want to integrate them into the project. So looking in the particle system file, what I will see here is the constructor doesn't take any information. Now it's set up right now, it does the 3 concentric rings with the particles. That's how it's choosing to animate at the moment. If you want 2 concentric rings, well then you change number of rings from 3 to 2. If you want 1, so it's just a blast of particles going out, you just put in 1 and we'll just see the particles just explode out from the middle. So now if I run it, oh wait, no, we won't see it yet because this is a non-functioning, the particles aren't actually working yet. So when it runs, we can change that number around and we can see how to play with it. Because what it does is it's now going to start setting the speed that it sends to each particle, and it's going to set a value for the speed of each particle where the value will be 2 plus then I divided by the number of rings, keeping the remainder instead of the how many times it actually divides in, and multiplying that value by 2. So in the beginning, I starts out at 0, so 0 divided by anything is still 0. 0 times 2 is still 0. So the speed of the very first particle in my array will be 2. The next particle as we go through, I is equal to 1. 1 divided by 3 is 0, remainder 1. 1 times 2 is 2. So 2 plus 2 is 4. So the first particle at a speed of 2, the second particle gets a speed of 4. Now, the third particle, so I is now equal to 2. 2 divided by 3 is 0, remainder 2. We keep the 2. 2 times 2 is 4, plus 2, that's 6. So my particles are going to have a speed of 2, 4, 6. Now my next one, I is now equal to 3. So 3 divided by 3 is 1, remainder 0. 0 times 2 is 0, so now the fourth particle has a speed, again, of 2. And what you will see is the particles will have this kind of repeating pattern of 2, 4, 6, 2, 4, 6, 2, 4, 6, 2, 4, 6, 2, 4, 6, until I've gone through all 100 particles. Now, technically, the math won't, there's not an even number of particles, because 100 divided by 3 is not going to be an even number, so there will be one extra particle moving at 2. But you can't tell. If you change the number of rings, that changes how many speeds our particles have, which then determines how they're going to then animate on screen. So then it would be 2, 4, 6, 8. And we just repeat that process. Now, if the number of rings is 1, then at that point it ends up being speed of 4. Or let's see, 1 times 2, yeah, or 2, speed of 2. So, but this ends up working that we can enter new rings, and it just keeps giving us more concentric circles. And it's kind of cool because we're using that repeating pattern of an increasing number divided by a fixed number gives us that, in this case, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, until you get really tired of saying that. So you can map it out. Now, you will notice the commented code here is where I was figuring that out of 248, 248, and working out the math to make this happen. And then I realized, I bet I could get it in one line, and then I wouldn't have to go, oh, I want to have 3 rings, so now I have to do the math differently. I want 4 rings, I have to add one more statement in my if. I'm like, well, that's stupid. There's got to be a better way. So the nice part about this is you can take this and just run with it, and if you change nothing, you get 3. If you only want just a single explosion of particles, you just set that equal to 1. Then you just goes out. So you can actually, you can even set it to 0, so there's no rings, so they will all have a speed of 2. Because then if it's 0, it's always going to, no, actually that 0 will fail because you can't divide by 0. I forgot, yeah, so don't do 0. That'd be bad. That's one of those, universal constants in math. If you divide by 0, it's an irrational number, which makes a computer freak out. So never ask a computer to divide by 0 unless you want it to. Normally it will check and go, oh, I'm not allowed to do that. But it is possible that you could make it happen and then it crashes the computer. So don't divide by 0. It's bad. It's bad. All right, so now that makes the particles. And then if we notice, the particle system is told that it's not ready. It has a Boolean value with it, is ready, which means when the particle system is ready and we switch that to true, that means we're going to be doing something with it. And we'll figure that out in just a little bit of how we might go about doing that. There's a populate method inside our particle systems. And we can see where that takes our particles and tells the particles to set their location. So if you remember, I mentioned that we need to somehow tell the particles where to start animating from. Well, the particles themselves have a method called set starting location. If we look in the particle class, we'll see set starting location. So that sets the x and y for the particle. And then is ready becomes true at that point. So what happens with populate is when a collision occurs, we will tell the particle system that it should populate the particles with the correct location that they need to start, and then it tells that particle system, now you're ready to run. And then if it's ready to run, we tell the particle system to run, and it's like, hey, if is ready is true, it's been made true, then it animates the particles, where it tells each particle to update and display, provided that particle is not dead. Which sounds, really bad. We're killing particles, but that's okay. They're just particles. They don't have feelings. They're kind of like neutrinos. There's thing I was reading about neutrinos in the paper today because some scientists got a Nobel Prize for parascientists for their work on neutrinos, which they thought originally were particles that had no mass, but because the particles are able to change their state, that means they must have mass. So now they've determined they do, and it's just like, wow, so much stuff flying right over the top of my head when I'm reading, going, yeah, my physics education stopped way too young to understand that. But it was really cool sounding. So we get to kill our particles. Now we can see particles kill themselves when their lifespan is less than 0. So they've run out of life, then they're dead. Now lifespan on the particles changes when they're updating. So they start out with a lifespan of 255. Now you may notice that their lifespan corresponds perfectly to, oh look, 255 is what we use for colors. So if we're using that, that also means we could be using 255 for alpha. And if we look at the fill color we're using for each particle, RGB, and we're using their current lifespan at 255 as an alpha value. Each time they update, it goes down, which is why the particles appear to fade out, because it's not even appearing, they are fading out. They're becoming increasingly transparent as they animate. And once they're no longer with us, that their lifespan has crossed the divide and is now a negative number, we've determined that they're dead because they're no longer, they're invisible. The transparency is less than 0, so we don't want to see them anymore. So that's how the particles die. Now, I would like to say I take 100% credit for everything contained in the particles and particle systems here, but I started with the tutorial files or the sample files that come with the program and then tweaked them to use code similar to what we're working with right now. So let's see, under simulate we have simple particle system. If I look at the simple particle system, we can see where we're telling particle systems to run, we're adding particles, okay, that's kind of like my populate, we're making them. Now this project uses the vector class. We did do the vector on it. There's a little bit of that kind of factored in using the sine and cosine, but I'm doing the math manually instead of actually using the vector class, which actually makes it a touch easier. But that's just one more layer of complexity. So if we tell a particle to update and display, we can see where, oh look, we have lifespan going on, so we're taking away from their life. The is dead looks, wow, surprisingly like, the one in the particle system that I just gave you. Yeah. So again, I'm putting credit where credit's due, that I modified this to fit within the constraints of what we are working on here. But this is now working a little bit differently because each particle, when it dies, it's ripping that particle out of the array list. So instead of using a standard array, standard arrays are fixed in length. When you create them, you fix their length. You say there's 100 objects in this. There's 100 objects in it through its entire existence. An array list has a dynamic length to it. So I can add things to it, I can remove things from it, and it doesn't freak out. So it's a different container object, because if you think of arrays as it's a container, it's a list of similar type objects. An array list is the same kind of thing, except I can now rip something out of the middle and the whole thing just collapses on it and gets shorter. An array, if I rip out in the middle, it doesn't, I can make that object no longer there, but there's now a hole. So arrays work a little bit differently than an array list. So this demonstration used an array list. I went back to just using an array because that fit with what we're doing in our project so far. So I use this as inspiration to build the particle system that we see here. So we have the lifespan for the fill color. Now it's drawing the ellipse on there. Is dead. Once the lifespan is too low, they go away. If you want your particles to last longer on screen, so they stream out longer, change the 5 to a different amount. If you want them to disappear faster, change the 5 to a different amount. That will help determine how quickly they blink out of existence. So these are the kinds of things of, if you think about, you're tweaking knobs and dials and other things to get the look and the feel how you want it to be. Anywhere you see a number in the file, it's probably a pretty good place to start messing with it to see, well, if I change this, how does that affect the playback or the performance of my project? Inside the intersect is where we need to start populating, telling our drops how to populate, and telling our drops then, let's get going here. So we need to tell that particle system, we'll tell our particle system at active PS to populate. Now, if let me just, populate takes 2 pieces of data. If I go back to the particle system and look at what populate says, populate says it's looking for an X and a Y location for the drop that got caught. The drop that got caught is drop, not drip, drops I dot. So we'll send it the X of the drop that got caught, and we'll send it the Y of the drop that got caught. Drop and got and caught. That's too many of the same sound in one sentence. So what we're doing is we're taking, because we said this drop, that's the drop we intersected with, so we'll say that drop, we'll use its X, we'll use its Y, and we will then send it to our particle system. Then what we need to do is we need to take active PS, because we've now used one of our kind of slots. We need to now send it, or make active PS become bigger. So it's going to be the same kind of thing that we see. Oh, missed. And then we tell it, so it's the same kind of thing like when we had active drops. So if active drops is less than the total number of drops, active drops went up by 1. So if my active particle systems is less than my total number of particle systems, active particle or active PS goes up by 1. We need to make our drops or our particle systems run. And currently the particle systems are not running yet, so we need to do that. Now, that takes place not inside this for loop that's doing stuff. It needs to take place. Oh, and I see we still have our little, when we hit rock bottom, we'll find out what that does in a little bit, or how to process that. But right now, we need to now tell all of our particle systems to run when they're capable. Now this is going to be pretty similar to what we tell drops based on active drops to update and display, but we're doing the same process with particle systems here. So I can just pull that up on screen here a little bit more. I'm going to put a comment in now. Tell the particle systems to run. So this is going to be using our standard for loop, but it's using active PS as our determiner limit of how many particle systems we want to tell it to run. So we have the for loop there, and then we just tell that particle system, PS, particle systems contains all of our particle, PS contains all of our particle systems. It's the array, so we tell that each one that is currently active to run. Oh, wrong button. Oh, we'll look at that in a moment. Want to format it. So we loop through our particle systems. If they're working, we can tell them to run. And it works. So now we've proven it can work, which is kind of cool. It's a good start to the process. We do have a little issue when we want to replay the game. We'll have to figure out how to get the particle systems to reset properly. So we'll have to work with that as well. And then we need to then figure out how to deal with hitting rock bottom. Particles work. We have the little problem that they tank if we try to go and access one too many of our particle system. So we need to reset things a little bit. Now, last class we came up with the brilliant idea. We reset a bunch of stuff here. Oh wow, I actually put comments in. I must have been on my game at that moment there. So before I make the game state go back to play, I think I need to go through and tell my particles to reset themselves. So I might want to reset the particles, and I may want to then also tell each particle to where it's supposed to go. And the only thing that really needs resetting on the particle when we look at this, the color that stays the same, but our lifespan needs to reset because that determines the opacity of our particle. And then we could go and set our Vx and our Vy down to 0 so we know that they're parked, because then they can reset themselves when it's time to. Actually, we don't even need to do that because that's determined by their angle and their speed. So if they're not animating, yeah, they're done, because we will reset their location when we replay the game. So when we replay the game and tell the particle, hey, it's time for you to start, we set your starting location. Because once the game runs, the particles are made, and then we can just keep resetting the starting location, reset their life at that point. Oh. Besides setting their starting location, we will just add in lifespan is equal to 255.0. Now the 0.0 on there is because sometimes when we're doing this, we may actually be doing the fade much gentler, so maybe only taking off a little bit per frame instead of a lot per frame, especially if the particles are moving slower. So then they just keep on going for a long time, looking real slow-mo. So if you want that, instead of taking off 5, I may be doing, say, 4.5, or I could be doing 0.5, which then the particles would go on nearly forever, it would seem. It's critical that we reset the lifespan when we start the particles. That way we don't have to have a separate reset function for them, because the X and Y location is kind of operating in that venue where we're saying, I want you to start here. So every time we go to reuse a particle, we can say start here, start there, start somewhere else. But we also want it to be fully opaque, which is the 255, since we're using lifespan as our alpha value when we create the fill. So as we're resetting the game, our particle systems, what we really need to do is just start over, because we reset all the drops. We set active drops to 0, so it would kind of make sense to follow that same method and set active PS equal to 0. So that now starts over, so we don't grab particle systems that are already in play. Now I have 10 particle systems, I have 10 drops, and I win my game when I catch 3 of them. So let's run this and see what I get. 1, 2, 3. Okay. 1, 2, 3. 1, 2, 3. All right, so I've now caught 12, 15, and it hasn't failed yet. That's good. So one line of code allowed us to reset our particle systems by just changing active part PS back to 0. So that reset the game. The next challenge before us is trying to figure out how to deal with the fact that when our drops hit the bottom of the screen, we want to have a negative impact on the scoring in the game so that we can lose. Because if we just play until we win, that's not that challenging. There should be some adversity that you have to fight against to win, so you feel some sense of accomplishment. So while we're cycling through drops, we can tell a drop to update, we tell a drop to display, we check to see if we have intersected the drops there. Now I'm going to put a comment here. Check to see if the drop has gone off the bottom of the screen. When you put in your comments, you can make them cryptic or you can be fairly verbose. There's no penalty in your performance of your code having long verbose comments. So make comments that make sense to you. So if the drop hits the bottom at that point, what we want to do is say, well, we want our score to go down by 1. So score minus minus. That takes away 1 from the score. If you're really mean, you get 1 point for catching a drop, but you lose 2 points if you miss a drop, which would make your game ridiculously annoyingly hard. But that could fit. If things are slow, so it's really easy to do it, then have more of a penalty for failing to catch. That would be something. And then if you wanted it not to be that, you could do minus equals, and then if you wanted it 2. If you wanted 1, well, that works too. Minus equals 1's minus minus, that's the same thing. But if you do it minus equals, then you could, oh, look, if I miss it, I lose 3, which guarantees, wow, if I miss 1, it's game over. Because it's a 3-to-1 ratio, that'd really stink. I'm going to leave it at 1, though, because I am bad enough when I play this, so I really don't need that extra negative reinforcement. So the score is going to drop by 1. Now we just do a check, and to continue with the thing is take away from player score. Now in the next line, we will check and say, check to see if the score is less than 0. If so, change the game state to lose. So that's the English of what we're trying to do. We're going to check to see if the score is less than 0, and if that's the case, change the game state to lose. To write it in computer speak, if score is less than 0, so if my score is less than 0, game state is equal to lose. So we can see the English version and the code version of the same thing. So if our score is less than 0, set the game state equal to lose. This now sets up the process to determine if a drop hits the bottom of the screen. We want the score to become less than 0, and then we change our game state to lose. We've worked it out. When the drops hit the bottom, we take away from the score. When our score hits a negative number, we've lost the game. But the drops don't know how to hit the bottom yet. If we look at the drop hit bottom is returning a false value. So that's not really giving us much yet. So we need to figure out how to work with that a little bit better. What we want to know is when a drop has hit the bottom, and if the drop has hit the bottom, then we want to kill that movement on it. And there's a couple of ways that we can go about doing this and working with it. So first off, what I'm going to do here is modify it so the drop doesn't just hit the height, but I want the drop to actually go a little bit further. So I'll go say height plus the radius of the object times 2. There we go, 2. That guarantees it's gone all the way off screen. Because when we start working with other shapes of objects or images and things like that, we really do need to start verifying that those objects are totally off screen. So this just pads it a little bit. It also means it won't register off screen until it's actually gone down a little bit. In this case, I think our drop is an R of 8, so it has to be at 16 more than the height of the document before it's off screen. And once that happens, well, we're not going to reset it here. I'm just going to comment that out. But I will just set then our speed y equal to 0. What happens is when the drop hits the bottom of the screen, boom, we're going to kill its speed. So it stops moving, because what we don't want is we're not going to handle our wrapping here. We're not going to make this happen, but we're going to let our hit bottom then find out, has our drop wandered off screen or done something. Now, if we look at the drops here, we'll see the drops, they always have this speed value of speed y. Right now speed y is 0 because we killed it. They start out with a speed of somewhere between 2 and up to but not including 7. So that's how our drops are falling, and you can change the numbers in your game, of course, to match. Now, under hit bottom, when we look at hit bottom here, one thing that we can check for is hit bottom could ask, hey, have you moved off screen? So we could ask, and once more, what's your Y position? But we could also just as easily say, hey, what's your speed? Because either the drop is moving, it has a speed of somewhere between 2 and up to, but not including 7, or it has a speed of 0. So we could ask and say, is your speed 0? Because if your speed is 0, that must mean you've gone off the screen. So if your speed is 0, you've gone off the screen. So if you've gone off the screen, that means you've hit rock bottom. And if you've hit rock bottom, then we want to take away from the score. So that's the process. Now, we could check speed, or we could do a duplicate check of the same way that we checked height here. We could be then checking height down here and repeat that. But I'm in a speed mood today, so we're gonna go with speed. Just going to put some extra returns in here just so it gets a little higher up on screen while I'm writing this. So I will be using this return. Actually, I'm just going to comment that one out. I'll add in a return false when I need it later. So if speed y is equal to 0, meaning our drop has gone off screen, we need to tell the drop to reset itself. Well, actually, I'm going to hold on that right now. Turn true, else return false. Oh, right there. There's the one I wanted. There's my previous here. So if our speed is 0, we've hit rock bottom. Otherwise, we haven't hit rock bottom. But the one thing is, we need to tell the drop at some point to reset itself, because right now it goes off screen, speed is 0, It acknowledges that its speed is 0, but it doesn't reset itself anymore because we took that out of our update. Previously in the update, it said, hey, if you've gone off screen, reset yourself. Well, but we don't want to reset it yet. We first need rock bottom to go, oh, by the way, you're off screen. And then rock bottom can, or hit bottom. I'd have to change the name just to fit with our play on words here. So at that point, we will say reset, like this. So if our speed is 0, we tell it to reset, and then we return a true message. Because our main game loop, it asks the question, it says, hey, drop, have you hit bottom? And if the drop checks and go, let's see, what's my speed? Oh, my speed is 0. Yeah, I hit bottom. We're good. And then it also resets the drop, so the drop can start animating again. But the game receives that message, so then it will subtract from the score. If we don't put reset in there each time a drop hits bottom, it won't ever return to the game. And then, that'd be bad. We don't want that. So now if I run this, and if my speed y, it says it cannot convert from a float to a Boolean. Well, I said speed y is equal to 0. Instead of asking the question, is speed y equal to 0? When we're asking a question, we use two equal signs. If we're assigning a value, we use a single equal sign. That's why it said it can't convert it from a float to a Boolean, because it's freaking out. So inside an if statements are always about asking a question. You're asking the question, hey, is this thing true or false? Because computers like that binary world of things being true or false, 1 or 0, on, off. So we say, hey, is speed y equal to 0? If so, reset. And by the way, I'll tell you that, yeah, it's true. Now if I look at the game, let me watch the score. I'll catch 1, 2, 3. Oh, I lost quickly. It works inside the drop class. I just had to modify. It doesn't like using the speed y equal to 0, but it does like where y, using the same y check if the y is greater than the height statement. If I reuse that statement in my hit bottom, it's working. I'm going to have to think a little bit more about why the numbers are different and why it's not working. But when I say the speed y is 0, then it was freaking out. And I couldn't increase the score. It behaved properly, but the score wouldn't display properly. But now if I go here, catch 2, and now if I miss 2, we see the score quickly cycles down, and now it's behaving.